All right, guys, let's do another one of these solving rational equations. We have a rational equation here. We need to solve it. So what's that going to look like? What are we trying to figure out? We're trying to figure out what does A equal? Because A is our variable. One variable, one equation. We can solve for A. So how do we do that? Well, the first thing I'm going to do is try to get rid of all of my denominators. How do I do that? I got to multiply it by something. I've got to multiply this denominator, or this, sorry, I've got to multiply this side of the equation by something. I've got to multiply this side of the equation by something. And that something that I'm going to multiply both the sides of the equation by has to have enough factors in it to cancel with all the factors of my denominator. So I got to figure out what's the factors of my denominators to figure out what that something is that I'm going to multiply. Okay, so what's the factors of this first denominator? Okay, that's actually kind of a tricky question. So here's you can see that it's this polynomial here is quadratic, so I can definitely factor it. So let's try to do that to figure out what the factors are. So it's 3a squared minus 6a plus 3. So the first question you always ask when you're trying to factor polynomials, can I take out a common factor? Is there a factor that's common to all three terms? So I've got 3a squared, negative 6a, positive 3. I notice with the 3 and the negative 6 and the 3, a 3 can come out of all those terms. So I'm going to take that 3 out as my GCF. So that's going to leave a squared minus 2a plus 1. Okay, so I've taken my GCF out. Notice I did not take an a with the 3. The reason is because a is not common. The last term's missing it, so it's not a common factor. Only 3 is a common factor between all three terms. So is there anything I can do to factor this anymore? Well, it's still quadratic. It's still got a squared a. So I should be able to factor it even more, or I should try at least. So I've got 3 terms here. I already took a GCF, so that's done. And I've got 3 terms left. And how do you factor a 3-term polynomial? Well, you got to use the a times c method. So what's my a term? So I got 3 terms. What's my a? My a is 1. And my b is negative 2. And my c is 1. So a times c is equal to 1 times 1, which is just 1. Can I factor a times c to make it equal to b? So 1 factors really into just 1 times 1. 1 times 1 equals 1. There's one more, though, because the negative times the negative equals a positive. So not just positive 1 and positive 1, I can do negative 1 and negative 1 as well. Which one of these adds up to my b? Well, the first pair adds up to 2. That's not negative 2. Negative 2 is my b. The second pair does add up to negative 2. So the second pair is the pair that I want. Okay, so I'm going to take my polynomial, a squared minus 2a plus 1, and I'm going to rewrite it with that middle term split up into 2. Negative 1a and another negative 1a plus 1. And that negative 1a and the negative 1a came from the negative 1, negative 1. Okay, so now I'm going to look at the first 2 terms, try to take a GCF out. And the GCF of those first 2 terms, what's that going to be? That's going to be a, and then what's left over is a minus 1. Now I'm going to look at those second 2 terms. What's the GCF there? I'm going to take out a negative 1. If I take out a negative 1, the negative 1a is going to turn into positive a. And the positive 1, taking out a negative 1, is going to turn into negative 1. And you can see that I've got these matching factors on both sides of my equation now. So I can divide that factor out and leave behind the a minus 1. Sorry, I messed that up a little bit. So how could I salvage that? A minus 1. All right, wrote that real tiny. Okay, real tiny. Now look at this. I've got 3 times a minus 1 times a minus 1. Something times itself, you can write that as squared, can't you? So if I took a minus 1, I just squared it. That means a minus 1 times a minus 1, which is what I have here. So these are 2 different ways to write the same group of factors. I've got 3 I've got a minus 1 squared. Okay, that comes to it comes to 3 factors. So let's rewrite this denominator the way that it's supposed to be, factored 3 times a minus 1 times a minus 1, which is what the squared does. Okay, so now I got to represent all my factors in my LCD. So how am I going to do that? Well, what's the factors of this first denominator? It's 3 times a minus 1 squared, which is just a minus 1 times a minus 1. Factors of my second polynomial, there's just one factor here, a minus 1, but that's already covered. I've actually got 2 a minus 1s here times each other. Okay, so that's already covered. Don't need to add another a minus 1. I've already got 2 of them here. And then I've got a 3, but the 3 is already covered too. 3 is covered. So that right there is my least common denominator, 3 times a minus 1. And the point of that is that if I multiply by everything, it's got enough in it to be able to cancel all of these denominators. So let's multiply all these rational expressions by that least common denominator. Let's distribute that inside. Okay, so we've got 3 times a minus 1 minus, let's see, 3 times a minus 1 and equals 3 times a minus 1. Okay, and then my first rational expression, bring that down, it's 1 over, and then the denominator, but in factored form, is 3 times a minus 1 squared. Oh, and I messed up a little bit, right, because my least common denominator is squared, so I got to make sure that I write it as squared for all my, there we go, squared, squared, squared. That's what I meant. There we go, that's better. Minus 1 over a minus 1 equals, okay, and 4/3. So I've taken my least common denominator, I've just brought down every one of these rational expressions and multiplied it by my least common denominator. Okay, now what can I cancel? That's the exciting part, because we don't like fractions. We want to get rid of those denominators. I can cancel those 3's. I can cancel the a minus 1 squareds. Now, this one's tricky. I've got a minus 1 times itself, and then in the denominator I've got just one a minus 1. So if I cancel the a minus 1 with one of the a minus 1's here in the squared, that's just going to leave one left over. That's as if there wasn't the squared anymore. So I can cancel out the squared with that a minus 1, leaving just one a minus 1 in the numerator. And then over here I can cancel those 3's out. So what do I have left over? In this first rational expression, the only thing that didn't get canceled was a 1. In the second rational expression, the only thing that didn't get canceled was I've got negative 3 times 1. So what that really turns out to be is just negative 3 times 1 doesn't change the value of the negative 3. And then I've got also times a minus 1, but not squared anymore because one of the a minus 1's up here got canceled with the denominator there. So just a minus 1, not squared. And then in my last rational expression, the only thing I got left was I've got a 4 out in front. 4 times a minus 1 squared. A minus 1 squared. Okay. Now, let's expand everything. Okay. And we do that by distributing. So I have 1 minus, I've got 3 times a, and then if I multiply negative 3 times the negative 1, I get positive 3. Positive 3. Okay, and if I want to check that, I can just multiply, or I can factor that and see if I really get what I started with. Factoring is the opposite of the multiplication I just did. So here I've got an interesting thing. So a times 1 squared is a times 1 times itself. So I'm going to just do a quick box method here to figure out what is a times 1, or a minus 1 times a minus 1. And I'm going to find that is a squared minus 1a minus 1a. So altogether that's minus 2a's, right? Minus 2a's if I combine like terms. And then plus 1. So I have 4 times a squared minus 2a plus 1. All right. Now what happens if I I can combine these like terms here. I'm going to have 4 minus 3a equals, I'm going to have 4a squared minus 8a, and then 4, so I'm just distributing the 4 in. I'm going to have plus 4. Okay. Now, I've got everything in polynomial terms, algebraic terms, okay, and that's what I want. But I want to get all these to one side or the other. Now, most of the terms are over here on this side. That's fine. So let me get these over there. How do I get rid of these? Well, I can get rid of the 4 by subtracting a 4 from both sides. I can get rid of the negative 3a by adding 3a to both sides. Adding 3a to both sides. So, negative 4, or positive 4 minus 4 is 0, and negative 3a plus 3a is 0. I've got 0 on this side. That's exactly what I wanted to have on that side. That's the whole reason I added and subtracted those things. But on this side, I've got 4a squared. Now I've got negative 8a plus 3a. Negative 8 plus 3 is negative 5a. And here I've got plus 4 minus 4, which is just 0. So now I've got a polynomial here equal to 0. How can I solve this polynomial equal to 0? Well, you remember from finding zeros, all I got to do is factor the polynomial. I can take out the common factor, which is a, leaving 4a minus 5. And then I can set each of the factors equal to 0. And I can solve for each factor. This one's already solved here. I've got a equals 0. And here I can just add 5 to both sides. Add 5 to both sides. And I'm going to get 4a is equal to 5. And then I can divide both sides by 4. And I'm going to get a is equal to 5 over 4. Now, the only thing I have to check is to make sure neither of these a values actually make one of these rational expressions undefined if you plug it in. So if I take a equals 0 and plug that in, I get 3 times negative 1 squared, which is just negative 1 times negative 1 is positive 1. 3 times positive 1 is 3. So if I plug in a 0, I don't get 0, which is good. That's what I want, which means this is really a solution, not an extraneous solution. If I plug a equals 0 in for this a, I get 0 minus 1 is negative 1, which is fine. You can have a negative 1. You couldn't have a 0, but it's not 0, so that's great. So a equals 0 works. We're good with that. A equals 5 over 4. Does that work? If I plug that in, I can already tell. I won't get a 0 because I'd have to subtract in 4/5, not a 1. So you can put that in the calculator if you want. You can plug the 4/5 in for a. See if it equals 0 in the denominator. And I'm just telling you right now, it won't. So both of these turn out to be real solutions. In other words, these are the answers. Solutions. Well, ignore the fact that I just misspelled the word solutions. And you have the right answer. Fortunately, I'm not taking off for spelling on the test.